Okay, so hello everyone. The question which we will be solving today is today's LeetCode POTD. Okay, as you can see, the question is maximum value of an ordered triplet 1, right? Okay, and like the question number is 2873 and it is marked as a medium one, right? Okay, so now let's just read the description and try to solve this problem. Okay, so you are given a zero indexed integer array nums. Okay. Return the maximum value over triplets of indices I, j, k such that I is less than j, which is less than k. If all such triplets have a negative value, return 0. The value of a triplet of indices I, j, k is equal to nums I minus nums j into k. Okay, so the question tells us what to do. Now it's up to us how we're gonna solve it. Okay. So like the first brute force approach, like see, you have given an array, right? You need to choose three indices I, j, and k, in which like I must be less than j and less than k. Okay, there are three indices, right? So and there's a condition in which you have to check and find the maximum answer. If you can't find, like if there is no such triplet exist, you just simply return 0, right? Okay. So what should be our first approach? Using three loops, and which will take like as the time complexity will be n cube, right? Okay. So like see, for this like this question in which we have 12, 6, 1, 2, and 7, right? I will start from here. J will start from I plus 1, so it will be here, and k will be starting from j plus 1, so k will be here. And for like each one we will be checking. Okay, so I don't think that it needs much deeper of an explanation. Okay, uh, you got it right. Okay, so like before moving to the next question, there is like a even worst approach which came to my mind, like not even like n cube. It was like let me just tell you, even worst approach. Even I don't know why it came to my mind. Like even I solved it using this approach. So what I was doing, I was like doing it by using the recursion. Okay, like using the pick not pick. Okay, so like for each index we were making two calls. So like it was a time complexity. It was taking a time complexity of this. Okay, so it was taking exponential time complexity. Okay, so you if you want to try, you can try it out. It will run because like the constraints are low, but yeah, this was also an approach which came to my mind. Okay, so like we have solved it using exponential time complexity, and we have also solved it using the n cube. Okay, so now what will be our second approach? Okay, now let's just observe the formula. Okay, what's the formula? Nums of I minus nums of j into nums of k. Okay, so we need to maximize, right? Okay, tell me one thing, when can we maximize? Like the this should be maximum, and what we are multiplying with should also be maximum, then we will definitely get a maximum answer, right? Tell me one thing, how can we maximize this? How can we maximize? This is a single number. Okay, so the choosing a number like which is maximum, it will or it will be maximum, right? Okay. Tell me how can we maximize this? Like if we choose a bigger I, if this is maximum and like suppose this is minimum, then automatically it becomes a maximum value, right? And this should also be maximum. So what was the formula? I is less than j, which is less than k. So tell me one thing, if I is maximum and j and like k is also maximum, so can we at each index find out what can be our answer? How? We have solved like such questions in which we do what? We find out the previous maximum because I is less than j, previous maximum, right? And next maximum. If we know at each point, we can solve it, right? Like we like it's not like strictly like it doesn't mean that if there is a 2 here, 3 here and 4 here, well, let's say 5 here, and we are like suppose 7, 8 and suppose like 10. Okay, so it's not necessary that for this 2 you need to choose 3 and like on the left hand side, and you need to like and you need to choose like 7 on the right hand side. It's not like that. It's more of like something like for this 2 you must choose 5 and for this 2 you must choose 10, right? Like on the left hand side what's the maximum value, and on the right hand side what's the maximum value that you need to find out. Okay, so let's just use this example and we can solve it. So what's the example? Like 12, 6, 1 to 7. Okay, so our array is something like 12, 6, 1 to 7. Okay, 6, 1, 2 and 7, and this is what our index is: 1, 2, 3, 4, 5. Okay, left max, right? Okay, so tell me, like this is nums. Okay, this is nums. Okay, this is left max. Okay, so tell me one thing, that what's the maximum value for the 12? No one, right? Like no one is maximum. Okay, so what can we write? So let's suppose we are writing an index. Okay, so can we write index minus 1? Okay, for this 6, what's the maximum value? The maximum will be what? 0, right? For this one, what will be the maximum value at the 0th index? Like, and for this also we will be having 0, right? Because 12 is the maximum on these. Okay, now let's just take the right max. Tell me one thing, that for this 7, what's the maximum value on the right? No one, right? Okay. For this 2, it will be 4, right? For this one, it will be 4, right? For this 6, it will be 4. And for this 12, it will be -1. Okay, now we just need to compute, right? Okay, so at index 1, what can be our answer? We don't have a left max and we don't have a right max. Okay, so it will be 0, right? This is our answer. Okay, so then we come to this. For this 6, what's the maximum on the left? It's 12 minus 6 into 7. What will be the answer? 12 minus 6 is 6 into 7. So 7 6 are, it give us 42. Okay, so 42 will be the answer here. Okay, so yeah, let's move forward. And so then we come here. Okay, so for this one, what's the maximum on the left? It's 12, right? 12 minus 1. What's maximum on the right? It's 7 into, so 12 minus 1 is 11 into 7, which will give us 77, right? Okay, okay. Now we move to this index, right? So for 2, what's maximum on the left, which is 12, right? Into 7, because that's maximum on the right. This is 10 into 7, which will give us 70. It will be 70, right? So then we move to this index. Okay, now for like 7, we have a left element, but we don't have a right element. Okay, so it will be 0. So by far, what's our maximum answer? It's 77, right? So the answer will be 77. So yeah, that's all like for this question. Okay, uh, today I won't be providing the code, like the, okay, so right, okay, so wait, or let me just get the code. Okay, just a second, I'll be getting the code. Okay, so yeah, I have brought the code. Okay, so see what we are doing. I have initialized two vectors, left max and the right max. Okay, like I have just calculated the size of the vector. Okay, so then I have taken the initial index as 0 and I have started the loop from I equals to 1, because like for the first index there won't be any left element, right? So I have considered it as a -1, and for the right also the same, like the first and the last, right? I have considered it as a 0, and n-1 I have taken it as a -1. Okay, so yeah, I have done it. And like if like left of I is equal to max index till left, and then I'm updating the index, right? IDX. And then for like the right part, I have reinitialized the IDX with n-1, and I've started the loop from n-2. Okay, which is going to 0, and I was just incrementing the value, updating the right max, and at last just storing the maximum index, right? And then what we are doing, I have taken a long answer, and I am checking for each index. Suppose if right max or left max is equals to -1, we are continuing, like skip the skip this part. Or if you can, or like you can start it from 1 to n-1. like uh, like n minus 2, right? Okay, yeah. And here we have just typecasted it because we're multiplying it, right? And checking if sum is greater than answer, we are updating the answer, and at last we are just returning the answer, right? Okay, so yeah, that's all for this code, and as you can see, the code is running just fine, and we have solved this question. Okay, so like the question and the code link will be in the description box. Okay, there you can check it out. So yeah, that's all for this question. Have a nice day ahead.